All right, good morning. And we are going to be doing questions 5 and 6 today on 2018. Number 5 is a polar graph, which is no longer on the test, but still good review, I guess, for us. So don't completely lose what we learned. And number 6, I think just like part A would be kind of what I would see being on the final exam. Part A, um, and that's about it. And then like we learn a method from part B, but mostly I think part A would be what we would need to know. But anyway, let's go ahead and jump into 5A. All right, so it says the graphs of the polar curves r equals 4, which we know is just a circle with a radius 4, so you can kind of see that that's the outer section of the r area. And r equals 3 plus 2 cosine theta, which is that little weird cardioid looking thing, are shown in the figure above. The curves intersect at pi over 3, so there's pi over 3, and 5 pi over 3, so there's 5 pi over 3. Okay, so those are our two intersections. And it says let R be the shaded region, which is shaded above, in the graphs of R equals 4, just between the two graphs. Write an expression involving the integral of the area of R. Okay, so remember that polar area is equal to 1/2 integration from a to b of r squared d theta. Okay, so in this case though we have two functions, so we have like two radiuses, so we're gonna have two of these. Now you always just got to be careful, like if it's always like outer function minus inner function, and if that ever changes over the interval, then you need to make sure you have a separate integration for that. But if you notice on this integral from pi over 3 to 5 pi over 3, that r equals 4 is always on the outside, so it's always the greater radius. So this is a pretty simple integration. It's just going to be 1/2 the integral from pi over 3, the small radius, to the big radius. So that's going to be doing a sweeping motion all the way around, all the way around. And what we're going to do is we're going to take the bigger radius, which is 4 squared, and subtract the smaller radius, which is 3 plus 2 cosine of theta squared. And that's our answer. That's all it wanted us to do, was come up with that integral. Okay, you don't have to solve it, so that's good. And you didn't have to solve for the intersections, which is also pretty good. All right, B. B says find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta plus at theta equals pi over 2. All right, so we're talking about just r equals 3 plus 2 cosine theta, and it wants us to know the slope. So what it's asking us to find is dy over dx evaluated at pi over 2. Okay, so we're going to have to build up to that, right? And yeah, if it says slope of line tangent, just make sure you know that's always dy over dx, not dr over d theta. Okay, that's the rate at which the radius is changing with respect to theta, not the slope of the tangent line. So, so we know how to find. Okay, so this is how it works. Remember how we find dy over dx. Dy over dx. This is just definition. Is the derivative, all right, of and I should say d theta, sorry, of r sine of theta, r sine of theta, divided by r cosine theta. Right, that's just the definition of dy over dx. You can think of it as parametric differentiation. It's the derivative of y divided by the derivative of x. And remember that y is just r sine theta, and x is just r cosine theta. So we're going to take the derivative of the top and the bottom. And remember, it's just chain rule, or I'm sorry, product rule. So r sine theta is going to be the derivative of the first, which is dr over d theta. Keep the second the same. Plus, keep the first the same. And the derivative of sine is cosine. That's over. The derivative of r cosine theta is going to be dr over d theta. Keep the second the same. plus, keep the first the same, and the derivative of cosine is negative sine of theta. And when we learned the derivative of polar, this is what we learned, and I told you can memorize this formula, or what I do, as you just saw, is I always just remember to take the derivative of y divided by the derivative of x. So, in order to figure out, I just need to plug in pi over 2 in for theta, but also other values that I'm going to need is dr over d theta, and I'm also going to need to know an r value to plug in. So we're going to get both of those from r equals 3 plus 2 cosine theta, right? To figure out the r value, it's just going to be r equals 3 plus 2 cosine of pi over 2. That's going to give me the corresponding r value, which is just 3. And if I want to know dr over d theta, evaluated at pi over 2, the derivative of 3 plus cosine, 2 cosine is just going to be negative 2 sine of pi over 2, which is just going to be negative 2. So we got our r, we got our dr over d theta, and we got our derivative function to plug stuff into. So if I plug in pi over 2 into all that, I'm going to get negative 2 sine of pi over 2, which is just 1, plus, and then r is 3, and the cosine of pi over 2 is just 0, over dr over d theta is 3, the cosine of pi over 2 is going to be 0, and then minus, again, the radius is 3, and sine of pi over 2 is 1. So this ends up being negative 2 over negative 3, which is 2/3. So there you go. That's the. I mean, that wasn't too bad, right? It was just kind of memorizing some formulas there. It was pretty much memorizing this formula, and then being able to get to here, and then knowing to find r, dr over d theta, and then just plugging in pi over 2. Okay, not the most terrible thing. We want to C. And finally, C says a particle is now moving along the portion of the curve r equals 3 plus 2 cosine theta, when between 0 and pi over 2. So that is, if I can draw it, that is that portion of the graph. Okay. And it says the particle moves in such a way that the distance between the particle and the origin, so between the particle and the origin on this curve, is saying that this distance right here is between the particle and the origin is increasing at a constant rate of 3 units per second. And if we're talking about the distance between the origin and the function, that's talking about the rate at which the radius is changing. So this is actually dr over dt. It's the rate at which the radius is changing with respect to time. And it says find the rate at which the angle is changing with respect to time. So it wants us to find d theta over dt when the position of the particle corresponds to theta equals pi over 3 and indicate the units of measurement. So I need to have some equation that relates dr over dt to d theta over dt. Well, here's that equation. So we're going to take the derivative of that, no longer with respect to x or theta or anything. It's going to be with respect to time t. So if I take the derivative of that, that's going to be dr over dt, that's the derivative of r, is equal to, the derivative of 3 goes away, and the derivative of 2 cosine is going to be negative 2 sine theta, and then d theta over dt. It's implicit towards time. All right. And then now all I have to do is just plug in my values. Like I know dr over dt, it says, is increasing at a positive rate of 3, negative 2, and this is going to be the sine of pi over 3. And we're solving for d theta over dt. So nothing too terrible. So it's going to be 3 equals negative 2. Sine of pi over 3 is square root of 3 over 2. And again, we're solving for d theta over dt. You notice the 2's can cancel. And then I can divide by negative root 3. So I got 3 over negative root 3 equals d theta over dt, which is fine to leave it that way, but let's see, d theta over dt, that does reduce down to negative root 3 if you want to reduce it further. And the units of measurement is, we're talking about d theta over dt, so that's going to be radians per second. Radians per second. There you have it. That was question number 5. I don't think that one was too terrible of a polar equation. I love it when they give you the graph, and I love it when they give you the intersections too. So that really helped a lot. Okay. All right, here's the answer key. So let's see. Part A, we got the constants and the limits and the integrand. I mean, that's exactly how we set it up. B's, if you look, this is all of B, and we didn't. I mean, they had 2 ways of doing it. We did not do it this way. We did it more this way. All right, where we figured out what dy over d theta divided by dx over d theta is. We did it more that way, and then instead of the bottom way. Okay. And then part C, again, they use kind of the notation instead of doing the actual math, but that's essentially what we did, except we just plugged in what the R equation was. And we got negative square root of 3 radians per second. All right. Cool. All right, let's move on to 6. Now, number 6, I realize can be kind of difficult, but again, I think part A is probably the only one we really need to maybe worry about as far as what's on the final exam. I could see that maybe being a topic, but so let's kind of refresh ourselves on that maybe. It says the Maclaurin series for ln of 1 plus x. So first of all, we know what Maclaurin series definition is. It's f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial. We know that formula, and we know how to use any function and find its derivatives, and we know how to simplify it down, but that's already been done for you here. It's already been done for ln of 1 plus x, and it told me the first 4 terms and the general term. Okay. And it says on this interval of convergence, the series is going to converge to ln of 1 plus x. Great. Okay. But we're going to let f be not ln of 1 plus x, but x times ln of 1 plus x over 3. Okay. So we have the Maclaurin series for ln of 1 plus x, but I want to come up with the first 4 non-zero terms and the Maclaurin series and the general term of the Maclaurin series for f. Okay. Now you could go through the whole definition of Maclaurin series. You could do f of 0 plus f prime of 0 times x plus f. You could do that whole thing out and do the whole process if you want. But what you want to do is what they're testing on is the fact that you can take a given Maclaurin series and build it into a new Maclaurin series, just given a couple different things. Okay. Notice how they're very similar, except for one is x divided by 3 and it has an extra x. So we're going to build that. Okay. All right. So we're given this. That's for ln of x, or ln of 1 plus x. Let's start by, okay, I notice I have 2 different additions here. I have the x divided by 3 and have the x. Let's start with building the x divided by 3. So I'm going to say the Maclaurin series for ln of 1 plus x divided by 3. Let's start with that. And all that's saying is instead of an x, plug in x plus 3. So instead of x, I'm going to have x divided by 3 minus, instead of x squared, it's going to be 1/2 x divided by 3 quantity squared. You see, all I did was just replace the x with x divided by 3. That's what it wants you to do. I'm going to have plus 1/3. Instead of x cubed, it's going to be x divided by 3 cubed. Minus 1/4. Instead of x to the 4th, it's going to be x divided by 3 to the 4th. Plus dot 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 plus. And then what we did at the general term is we still have the alternating piece, but instead of x, we have 1/n, okay, and then we have x divided by 3 to the nth. Okay, and I brought out the 1/2, the 1/3, the 1/4. You could have honestly left that all still divided by. I just brought out the fraction. Okay. All right. Now the next thing we need to do is we need to then just multiply everything by x, and then we have our answer. And that's it. Okay. So x divided by 3 times x is going to be x squared over 3. And then minus, okay, so x squared times x is going to be x cubed. And I'm going to go ahead and say on the bottom that's 2 times 3 squared. Okay, I just went ahead and distributed the square to the 3, and then just went ahead and multiplied it by the 2 on the bottom. And then plus x cubed times x is x to the 4th over 3 times 3 cubed minus x to the 5th over 4 times 3 to the 4th. Okay, I'm just multiplying everything by x and simplifying a little bit. Plus dot 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 plus. All right, so we are alternating part negative 1 plus negative 1 to the n plus 1 still stays the same. And notice what the pattern is now. So if you notice up here, like this x term, we're starting with the first term instead of the 0th term. We're starting with the linear term instead of the constant term. So if you notice this right here, okay, that's my first term. This is my second, third, fourth. What it's going to be is now instead of x to the n, it's x to the n plus 1. That's what happens when you multiply by the x. You're just changing it from, you're just adding an extra power of x to the general function. And then divided by, it's still n, and then just times 3 to the n. And that's our first 4 terms. And that's the general term for x, ln of 1 plus x cubed. We did 2 substitutions. We built it twice to get to this point. Okay, so I mean, I don't know. I don't think that was the worst thing in the world. We got to get good at building, I guess. All right. So then B says determine the interval of convergence of the Maclaurin series and show the work that leads to your answer. Okay, so we don't like on our final exam, finding the interval of convergence of the Maclaurin series is no longer a requirement. But the test we use to do that is a test for convergence that we need to know, so it's still good practice. So if you remember, finding the interval of convergence for Maclaurin series comes from using the ratio test, which we need to know how to do the ratio test. And remember, that is simply saying to do the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n, and that needs to be less than 1. That's the interval of convergence. So we need to figure out what x values makes that happen. So what I'm going to do is I'm going to say the limit as n approaches infinity of the absolute value. Now a sub n plus 1. It wants me to do this for f, which I came up with the general term in the last problem. The last problem was, and if you look back here, this is the general term I'm using right here. And remember that when I do absolute value with the negative, that doesn't matter unless it was something other than negative 1. But just being negative 1, the absolute value of that goes away. So really, this is what I'm worried about here. Okay. So a sub n plus 1 is going to be, just looking back at that previous problem, instead of x to the n plus 1, it's going to be x to the n plus 2 over, instead of n times 3 to the n, it's going to be n plus 1, 3 to the n plus 1. And then times, because we're dividing by a sub n, so I'm going to do same change flip. It's going to be n 3 to the n over x to the n plus 1. Okay. Which, remember how we simplify this. X to the n plus 2 and x to the n. The x to the n's cancel, so I'm left with x squared over x, which is just x on top. And then the 3n and the 3n plus 1, the 3 to the n's cancel out, so I'm left with just 3 on bottom. And on top, I still have the n, and on bottom, I still have the n plus 1. All right, which if we take this limit, remember that we're taking the limit of n, so since we have the same power on top and bottom, it's just going to be the leading coefficients. So this limit is equal to the absolute value of x divided by 3. And I'm trying to solve for the interval where this is less than 1, which is simply x is going to be less than 3 and greater than negative 3. Okay. So right now, that's my answer. That's my interval of convergence. The only thing is, though, is we got to test those endpoints to see if we include them or not. Okay. And we test those endpoints by plugging them in to my series a sub n. Okay. So we're gonna first test. Let's let x equal -3. Okay, and if I let x equals -3, so that's going to be the summation n equals 1 to infinity, and it was -1 to the n plus 1. From part A, it was x to the n plus 1, so this is now going to be -3 to the n plus 1 over n times 3 to the n. Okay? Which, if I simplify this, if I take the if I take the -1 here, if I take out this -1 here, that's going to be -1 to the n plus 1 times -1 to the n plus 1, which just becomes +1. So all I'm left with on top is 3 to the n plus 1. The negative with the 3 and the negative with the alternating piece here cancels out. So I'm left with 3 to the n plus 1 on top. And on bottom, I got 3 times 3 to the n, which again is going to reduce a little bit further. The 3 to the n and the 3 to the n cancel out, so I'm left with 3 to the first on top and n on bottom. So, does this series converge or diverge? Well, if you compare it to the harmonic series, or if you think of this as a p series, this has a p-value, p equals 1, all right? And by p series or by harmonic series, you can say that this diverges. And we'll say by, why are you not, oh, I don't like that. This, we'll just say this diverges by p series, or you can say diverges by harmonic series. Okay. And so we do not include -3 in the interval, but if I try again, if I try to let x equal 3, this is going to be the summation n equals 1 to infinity of -1 to the n plus 1. Instead of -3, it's +3 to the n plus 1 all over n times 3 to the n. I'm running out of space here, but if I let x equal 3, the 3 to the n and the 3 to the n cancel. So I'm left with, again, what I had before. I'm left with 3 on top and just n on bottom. So this is the same thing as before, but this is an alternating series now. So where my alternating piece is -1, but my a sub n is 3 over n. So if I do the alternating series test of convergence for this, it does satisfy it. So this does converge. And again, you can test that if you remember that the alternating test was number 1, that the limit as n approaches infinity of a sub n if it equals 0, and the limit of 3 over n does equal 0. And number 2, that the derivative of that, or that it's always decreasing. So if I take the derivative of 3 over n, I have -3 over x squared, which is less than 0. So we're good there. So because the series is always decreasing and that the limit equals 0, then I know it converges. That's just the alternating series test. So I know that I'm actually going to include 3 in this interval, but not -3. Okay. So we did the interval of convergence by ratio test, and then we tested each of the endpoints. I tested -3 by p series, and I tested x equals +3 by doing the alternating series test. Okay. All right, cool. And lastly, C, right? Yeah, C. It says let's have a fourth degree Taylor polynomial. Let's let p sub 4 be the fourth degree Taylor polynomial for f about x equals 0. So from part A, it's just going to be those first 3 terms. Okay, it's going to be that term x squared, x cubed next to the fourth. It says use the alternating series error bound to find an upper bound for this right here. And all that's saying is the difference, or the difference between the actual value for what f of 2 is. So like if I plug 2 if I plug 2 in for x here, like 2 times ln of 1 plus 2/3, it wants to know like the difference between that and the approximation I get from the first, from all the way to the 4th power of the Taylor polynomial. So remember how the alternating series bound works is, I always write it this way, that the sum minus the partial sum is always less than or equal to um, the next term. So I call that a sub n plus 1. So in this case, if I'm going up to the fourth power, then the next term is going to be the fifth power. Okay, that's the next term in the sequence. So how this is written, and I always write it this way, I say f of 2 minus p4 of 2, which is the same thing because we're taking the absolute value, is going to be less than or equal to the next term in my list. So that's the fifth power, which if you remember from my answer in part A was the absolute value of, it was a negative term, but the absolute value is going to cancel out anyway, of x to the fifth, so 2 to the fifth, because that's the x value I'm approximating, over 4 times 3 to the fourth, which this is equal to, absolute value gets rid of the negative, so I'm just going to go ahead and forget the absolute value part. And 2 to the fifth is 32. On bottom, it's 4 times 3 to the fourth is 81. And this is 8 over 81. Okay, so there's my upper bound. All right, that I know the difference between the actual value at x equals 2 and the partial sum to the fourth degree with 2. I know that difference, that error, is going to be less than or equal to the next term, which is with 2 plugged in, which is 8 over 81. And that's it. That's all we had to do for that one. So here's our answer key. First 4 terms, check, and the general term, check. For part B was with 5 points. So we did the ratio test. So we set up the ratio test and computed the limits of the ratio and got the radius of convergence to be between -3 and 3. We did not do this piece. That was the other way to talk about the radius of convergence, but anyway. And then we checked the endpoints and concluded our final answer. So we did the ratio test for the interval convergence and then tested x equals 3 and x equals -3 and got 5 points. Okay. And then in part C, we did we used the fifth degree term as my next term in the list. And then we got our answer to be 8 over 81. Okay. All right. So that was questions 5 and 6. We just finished up 2018. We will finally finish the most recent released questions, 2019, the rest of this week. All right, so under 30 minutes today. Good job, guys. Let me know if you have any questions. See y'all.